In this screencast, we're going to learn how to solve different types of equations other than linear and quadratic equations. And the first type we're going to look at is radical equations. And they're called radical equations because they've got radicals in them. Okay, so in this case, I've got a square root of x minus 3 equals 2. And the thing we want to do is get rid of that radical. So I'm going to square both sides. And the key word is sides. I'm not squaring individual terms, I'm squaring each side of the equation. So when I square the square root of x minus 3, I get x minus 3. And when I square 2, I get 4. So x equals 7. Okay, so let's look at this one. Now instead of a number over here, I've got a variable. Well, we're going to treat it the same way we did the last example. I'm going to square each side. And I get 2x plus 3 on the left and x squared on the right. I'm going to get everything over on one side. So I'm going to subtract the 2x. I'm going to subtract the 3. This is a quadratic, so we'll solve it by factoring if possible. And I think this is possible. We'll do a minus 3 and a plus 1. So x equals 3 and negative 1. Okay, now since we squared the sides of the equations, we kind of changed the problem. We increased the degree, so we need to check our answers, okay? So I'm going to put in 3. So is the square root of 2 times 3 plus 3 equal to 3? Well, 2 times 3 is 6, plus 3 is 9. The square root of 9 is 3. So that one works. Okay, how about this? Is the square root of 2 times negative 1 plus 3 equal to negative 1? Okay, so I have negative 2 plus 3 is 1. The square root of 1 is not equal to negative 1, so we have to toss this answer out. So remember, if you get more than one answer, if you're dealing with a quadratic, you need to check every answer and make sure it works. In this case, only this answer works. Okay, let's do this example. So now we've got a binomial on the other side. I'm going to square both sides. So I've got the square root of 2x plus 6 being squared. And remember, we're squaring the entire side, not the x and the 3 separately, but together. Okay, so over here I have 2x minus 6. Over here, remember, we're going to do x plus 3 times x plus 3. That will give us x squared plus 6x plus 9 when you do FOIL on that, okay? Getting everything over on one side. X squared plus 4x plus 15. Whoops, I made a mistake, didn't I? That should be a plus right there, which is going to change that. I'm going to get a 3. And now we can factor x plus 1, x plus 3. So x equals negative 1 and negative 3. All right, let's test them. Is the square root of 2 times negative 1 plus 6 equal to negative 1 plus 3? Okay, that's negative 2 plus 6 is 4. Square root of that is 2. Negative 1, yes, so that works. We'll use it. Now, is the square root of 2 times negative 3 plus 6 equal to negative 3 plus 3? So I get negative 6 plus 6, which is 0. The square root of 0 is 0. So we'll take both these answers. They will both work. Okay, so now we come to the most complicated type of radical equation, which is when you have two radicals. Here's what you do. You isolate one radical. In other words, you get one radical by itself on one side. I'm going to square both sides. I get x plus 2, so that radical's gone, but over here, I'm going to write this out for you. And we're going to do FOIL. Whoop. Okay, so 6 times 6 is 36. I get a negative 6 radical minus another 6 radical is minus 12 radical 7x plus 2, and then radical times a radical gives me 7x plus 2. Okay, now we're going to isolate this radical and get everything else on the other side. So I'm going to subtract 7x, which is going to give me minus 6x. I'm going to subtract 38, so it's going to give me minus 36 equals negative 12 radical 7x plus 2. I'm going to divide everything by negative 12, so I'm going to get 1/2 x plus 3 equals the square root. I don't have to divide by negative 12, but I just decided to do that. It'll work fine if you don't. Okay, square both sides again to get rid of this last radical, and I'm going to get 1/4 x squared plus 2 times 1/2 x times 3 is 3x plus 3 squared. And over here I get 7x plus 2. I don't like that 4 there, so I'm going to multiply everything by 4. So I'm going to get 1x squared plus 12x plus 36 equals 28x plus 8. So x squared, 28x. So x squared minus 16x plus 28 equals 0. And this factors into x minus 2, x minus 14. So x equals 2 and 14. Now we need to check both of these in the original problem. Okay, so hang on, I'm going to pause this, copy and paste. Okay, so I've pasted it here for us, and I'm going to try out 2. So is the square root of 2 plus 2 plus the square root of 7 times 2 plus 2 equal to 6? Let's see. Okay, that's going to be the square root of 4, which is 2. 14 plus 2 is 16. So that's 2 plus 4. Yes, that works. How about 14? Okay, is the square root of 14 plus 2 plus the square root of 7 times 14 plus 2 equal to 6? Let's see, that's 4 plus, now, you know what, 7 times 14 plus 2, the square root of that is going to be a lot bigger than 2, which is what it would have to be to equal 6. So I'm going to say that 14 does not work, and the only answer we're going to use is x equals 2. The other type of equation we're going to solve are equations in quadratic form. So you'll notice that I have the first term is squared, and the second term is the same as the first, but it's to the first power. So this is in the form of ax squared plus bx plus c equals 0. Okay, so I'm going to pick a temporary variable, we'll say a. So I'm going to let a equal 2x plus 1. And I'm going to rewrite this equation here in terms of a. So now it becomes a squared plus 5a plus 4 equals 0. And that factors a plus 1, a plus 4. So a equals negative 1 and negative 4. However, the original problem was written in terms of x. So that means I'm going to take this negative 1 and I'm going to put it in right there. So I'm going to say negative 1 equals 2x plus 1. Subtract 1 from both sides. And x equals negative 1. Then I'm going to put in negative 4 and set it equal to 2x plus 1. Subtract 1 from both sides. And x is negative 5/2. So we get two answers, negative 1 and negative 5/2. Last one, you'll notice that this is the square of that, so it's in the quadratic form. We're going to let a equal x squared. That means this becomes a squared minus 3a plus 2, which factors into a minus 1, a minus 2. So a equals 1, a equals 2. But remember that a is actually x squared. So x squared equals 1, and x squared equals 2. So x equals plus or minus 1, and x equals plus or minus the square root of 2. Notice, how many answers do we get? 1, 2, 3, 4. And look at the degree. The number of answers you get to an equation will equal the degree.